Hello, everybody, and welcome to this evening's talk from the IET Sussex Local Network on reducing the carbon footprint of your building. Now, this is in fact the last talk of our season for this year, the 21-22 year. So I'd just like to remind you that our 23-24 programme will in fact start on the 4th of October with a lecture on energy transition at the Horse Theatre in Crawley. Okay, now this evening, this is a totally Zoom talk, and so any questions you have during the talk, I'd like you to use the Q&A button at the bottom of your screen. Your microphones and your cameras will be muted, and in a moment I will hand over to Chris to talk through this evening. And then afterwards, I will rejoin for the Q&A session at the end, read out your questions. Chris will then answer them. So moving on to tonight's talk, reducing the carbon footprint of your building. Chris Collier is an engineer by training, whose career has been in the field of sustainability and energy efficiency. About 12 years ago now, he started his own consultancy based here in Sussex, assisting with the drive towards low carbon buildings. Therefore, his talk tonight is going to be about the progress we've made over the last few years, moving towards low carbon for our built environment, and some of the trades and the decisions that we're going to have to take moving forward in the future to achieve zero carbon by 2050. So with that, I will now mute myself, hand over to Chris, and rejoin you for the Q&A at the end. Over to you, Chris.
Thanks very much, Greg. I'm just going to share my screen. If you could stop your sharing, Greg, when you're able to. Right, good evening, everyone. I hope you can all hear me. I'm sure you will notify me if you can't. So as Greg mentioned, I'm going to be speaking tonight about reducing the carbon footprint of your building. I studied mechanical engineering, and I'm currently actually a part-time master's student in sustainability at Cambridge, which is where I've sort of derived a lot of the sort of content of tonight's talk. It is related to the work that I do in sustainability and energy efficiency, but I think you'll see it goes a bit beyond that and sort of looks at the challenges and possible solutions that we have coming up in the sort of build up to 2050. So just to, I'm sure a lot of this will be common knowledge to many of you, but just to give a bit of background on the sort of status quo and looking at a global CO2 emissions at first. It's a well-known figure that the construction industry accounts for approximately 39% of global CO2 emissions, and that's breaks down further into 28% operational energy or carbon, and 11% what we call embodied carbon. So just looking at this graphically, if you can see my mouse cursor, the pie chart on the right shows the sort of global CO2 emissions breakdown, and you have transport there, 23%, other industry. This is looking, you know, in quite broad terms, but that's 31%. But the biggest chunk of the pie is the construction industry as a whole, and the operational carbon. When I say operational, I mean while the building is in use, using it for lighting, heating, ventilation, hot water, computers and hair dryers and that sort of thing. That's all operational energy. And then the smaller chunk of that pie, but still in the construction industry, is what we would sort of term the embodied carbon, the actual carbon that goes into the manufacturing of the products and materials and the construction of the buildings. So you can see it's a massive part of global CO2 emissions. And of course, we're aiming to be limiting global warming to no more than 1.5 degrees by 2050. Coupled with this, we have a growing population supposed to increase to 10 billion people by 2050. And in order to house those people and provide workplaces for them, we're meant to be adding more than 200 billion square meters of floor area by 2060. So these are startling figures, I'm sure you'll agree, and it sort of sets the scene for what's to come. Now, sort of drilling down into what we've done in the UK, we've mainly been focusing on operational energy and carbon. If you remember from my previous slide, that's the sort of lighter blue part of the pie there, which is the bigger chunk at the moment. And the way that the government has sort of implemented this approach has been through carrot and stick, really. The building regulations part L deals with energy efficiency in domestic and non-domestic buildings. That's for both new and existing buildings. We have the EPC ratings, which I'm sure many of you are familiar with if you've bought or rented or sold a house. And then on the incentive side, there has been, unfortunately no longer is with us, but we had the feed-in tariffs for renewable energy, solar PV, and the renewable heat incentive for renewable heating. A lot of progress has been made actually in the last sort of decade and a half. This chart shows quite neatly how EPC ratings have improved in the UK. And remember, EPC ratings are purely looking at operational energy. So going back to 2004, we had very few A and B rated buildings. We had a number of C, a number of D rated buildings, but mostly E, F, and G. And as you transition up to current day, this only goes to 2019, so it should look a bit better now. We've got at least some A and B buildings, but a lot of C rated buildings and practically no E, F, and G rated buildings left in the building stock. So there's been a massive improvement here in the energy efficiency of UK building stock. And this is what we would consider dealing with the low-hanging fruit, really. I mean, I guess you could say it's been relatively easy to achieve this. It's perhaps not the whole picture, though, and I'll explain why in a minute. But first, I wanted to also look at where some progress has been made, and this is in terms of the decarbonisation of the UK electricity grid. There's been a massive decarbonisation here, going back a decade. In 2012, the SAP here refers to the methodology for calculating EPCs. So in 2012, and this is the sort of national standard figure that's used, it was 0.519 kilograms of CO2 for every unit of electricity. And that's come down a decade later to about a third of that value, in fact, less than a third, 0.136 kilograms CO2. And just to look at this graphically, we've got a comparison there, the yellow being gas, which obviously hasn't changed much, being a fossil fuel, but electricity, which was a lot higher than gas back in 2012 in terms of carbon intensity, sort of leveled out about 4 years ago, and now is actually less carbon intensive than natural gas, which is quite startling. This is obviously to do with getting rid of coal power stations. I'm sure everyone is aware, coming on board new wind power station, wind turbines and nuclear power stations. So, you know, massive decarbonisation there. Further energy efficiency improvements have been made in terms of lighting consumption, probably by about a factor of 10. If you think about halogen and tungsten light bulbs of the past, they're no longer with us. LED lighting has been an amazing solution there to reduce energy consumption of lighting. And naturally, the government is going to be promoting electric heat and electric transport because of this decarbonisation of the grid, which all sounds like very good news so far. But we need to look at what this means for retrofitting our existing building stock in the UK, and what does it mean for the whole life carbon emissions of the retrofit measures. So there is an impact on the operational energy when, the operational energy savings become far less impactful as the grid decarbonizes. Now, this might be sort of counterintuitive, but basically, if we look at our pie chart from earlier, the embodied carbon of materials and products that go into our buildings becomes far more significant in the overall picture when you consider, or when the operational energy decreases. So to sort of demonstrate this, remember this is sort of looking at the fraction of 100%. So although the absolute figures might be shrinking, in percentage terms, we have the same size pie. So if we consider that the improvements in operational energy makes the embodied carbon suddenly a much bigger piece of the pie. And so this then begs the question, should we now be focusing more on the embodied carbon of buildings? And the question is really, will there be a shift in UK policy as a result of this? The London plan has already acknowledged the importance of whole life carbon, and they in fact require a life cycle assessment but only for sort of major or referable development. That's 150 plus units. That's projects that are referable to the mayor. So this is progress in London, but it has not yet been carried through into sort of national building regulations throughout the UK. The focus is still currently on operational energy and carbon. In fact, there's very little focus at all on embodied carbon of retrofit throughout academia and industry. And there are a number of papers. This one in particular, one of our tutors at the university has been looking at the sort of lack of, statistically, the lack of academic papers focusing on these issues. So what we have developed as part of one of our group projects at the university in sort of the recent months that I've been working on this project is what we call a matrix tool, simply because the film came out recently, Matrix Reloaded, but it is a line of numbers in a spreadsheet. And we are using this tool to analyze the embodied carbon cost versus the operational energy savings. This is sort of like similar to a financial case where you have an upfront cost and annual savings. We're looking at the carbon cost versus the operational savings, trying to get an idea of how long it takes to pay back the upfront embodied carbon. I have a video which I'm going to try and play, and hopefully the audio works, which is a very silly but hopefully explanatory video into what this tool aims to achieve. So I'm going to try to play that now.
Hi, Stephanos. I've got an old house and it's very cold. I was thinking of upgrading with some retrofit measures to improve the energy efficiency, but I'm worried about the carbon cost of making those changes. Can you help?
Of course I can help you, my friend. I am Greek. I know everything. I have the perfect metaphor for this. You just have to bear with me for a while. Κοίτα αυτόν εδώ τον αρκούδο τώρα. Αν το σκεπάσω, αυτό σε τόρνη θα είναι το όζον.
Yes, the video is meant to be playing. If you can't see it,
we can hear it, but we can't see it.
Okay, I'll try to stop my share and then start it again on the screen for the video. Apologies. Thanks for letting me know. Right. How about now? Can you see the
I can see a Hollywood production clapperboard.
There we go. Okay, I'll start again. Apologies for that. And just checking you can hear the video.
Can't hear anything at the moment. Is it playing?
Hi, Stephanos.
Yes.
I've got an old house and it's very cold. I was thinking of upgrading with some retrofit measures to improve the energy efficiency, but I'm worried about the carbon cost of making those changes. Can you help?
Of course I can help you, my friend. I am Greek. I know everything. I have the perfect metaphor for this. You just have to bear with me for a while. Κοίτα αυτόν εδώ τον αρκούδο τώρα. Αν το σκεπάσω, αυτό το σεντόνι θα είναι το όζον. Και αν πάρω αυτό εδώ το νηστέρι και κόψω λίγο, τι θα βρω από μέσα? Θα βρω μια μόνωση. Και άλλη μόνωση. Αλλά, αν ψάξω πιο βαθιά, τι θα βρω? Κάρβουνο. Και τι είναι το κάρβουνο? Άνθρακα.
Sounds like you need the Matrix.
Plug in your house type, choose your retrofit items, and our matrix will calculate how long it will take to pay back your embodied carbon based on the operational savings.
I'm thinking of upgrading my boiler too, moving away from gas, moving towards an electric boiler. But how does that work in terms of electricity usage and the decarbonisation of the grid?
Oh, you know what? I have an answer for that too, my friend. But I don't think Teddy is gonna like that very much.
And don't worry, we'll also be considering the financial costs and the decarbonisation of the grid.
Right, I will try to share my main screen again. Bear with me. Use the pun once again. Can you see the presentation screen, Greg?
Yes.
Okay, great. So yes, that was not meant to be too serious, clearly, but that just sort of explains what the intention of the project was, and you know, how we're going to go about creating some sort of meaningful data that could be used to work out the payback time for your upfront embodied carbon. As I mentioned, that's sort of similar to a financial payback calculation. The difficulty here being trying to collaborate all the information for the different components that go into a retrofit to calculate the embodied carbon cost. But basically, if we invest X amount of carbon at the start of the retrofit, how long is it going to take the carbon to be paid back? And that's sort of our overarching question. So a couple of case studies. Here is a sort of terraced street that, interestingly, one of the properties didn't wish to be included in the retrofit, and it's quite clear which property that is. But it does show a nice sort of picture of before and after, and it makes it quite obvious what the retrofit measures were. We would consider this a deep retrofit. The whole building has been enveloped in a external insulation, and there's clearly solar panels on the roof. The windows have all been replaced. And this is a company called Energy Sprong. I wasn't personally involved in this project, but it is a very interesting one when looking at embodied carbon. Clearly, there will be energy savings here, but yeah, the embodied carbon is another factor. A project that I was involved in was a retrofit, and in fact, moving of a building from one London borough to another, and some photos of the process of moving the modular building shown there. Here we showed that there was a huge embodied carbon saving purely because there was no demolition involved in the previous building, and there was no, well, very few new materials required in setting up the building in its new location. So a huge amount of embodied carbon was saved. There was some new, there was a concrete slab added, and this obviously had to be factored into the calculation. We calculated the embodied carbon of the solar PV panels, but in short, there was a huge embodied carbon saving compared to putting up a new building in its place. So some of the interesting findings of our tool that we have so far, and it's kind of a work in progress at the moment. We have looked at one case study where we have about a 15 to 20 year carbon payback on a whole house retrofit. Now, this wouldn't sound great perhaps as a financial case for a domestic scenario. I don't think many people would be happy waiting 20 years to see a payback on perhaps solar panels or something like that. But perhaps that's okay when you're looking at carbon. The building should outlive most of us. And, you know, if we're talking about a 100-year lifespan of a building or something in that sort of order of magnitude, then perhaps 15 to 20 years carbon payback is okay. This was actually a 3D model of the case study building. It was a mid-terrace building. What we found is that the results are very heavily influenced by the future energy scenarios. What I mean by this is the National Grid sort of has produced for the UK government a set of scenarios which they believe are potential routes that the electricity grid will go. So we have a starting point in 2020 where we are now. Actually, we've moved on a bit. So we, as I showed you in one of the earlier slides, the current carbon intensity of the grid is about 0.14, 0.136 kilograms CO2 per kilowatt hour. Now, there are various trajectories that the UK electricity grid could go depending on whether we don't do much or whether there's a sort of leading the way progression where a lot is done to decarbonize the grid further. Now, you will notice that 3 of these scenarios actually dip below 0, and I won't go into this in too much detail. Suffice to say, there is a debate on whether that's actually possible. This would obviously need to be biomass coupled with carbon capture and storage in order for there to actually be negative emissions. But it creates very strange results in our tool, or in any calculation really. When you start to have negative emissions from the grid, it actually, you know, nonsensically encourages you to use more energy because it seems that this would take more carbon out of the atmosphere. So what we've done to deal with this anomaly is just to set the graph to hit 0 and flatline at that point once the grid has fully decarbonized, which works, probably makes a lot more sense to get some meaningful results from the tool. Some of the strange results we had were, well, I say strange, but it's actually, it makes sense. The carbon payback gets longer as the grid decarbonizes. So, you know, as I said earlier, the energy savings you make become less impactful over time as the grid decarbonizes. And strangely, in this case study, adding solar PV actually increased the number of years it took to pay back the carbon. That won't necessarily always be the case. Solar panels here were fitted in 2009, I think, and PV technology has come on since then. So perhaps that wouldn't be the case adding PV panels today. But certainly that was what we found for this case study. Historically, there has been a strong correlation between cost savings and carbon savings. And so it's understandable that we would think that anything that's going to save money is also going to be good for the environment. However, we perhaps need to change our thinking about this. It is not necessarily the case that carbon saving measures will in fact be good for the environment. I'm talking about operational carbon savings. under certain scenarios, actually the upfront embodied carbon never gets paid back. And you know, in an ideal scenario, you would have a graph which looks like this, where the initial upfront carbon sort of puts you, there's a premium to pay there in terms of carbon. And then as you get your annual savings, you have a break-even point. In this case, it's about the year 2027, where you're actually now, after your retrofit measures, you've sort of broken even. You are carbon neutral just for those retrofit measures. And then in the years beyond that, you actually start to see your savings, your carbon savings. This is the sort of period of time where you're doing good for the environment. However, you can get scenarios like this where if you have a very high upfront embodied carbon, i.e. the measures that you've taken, say the insulation product that you've selected, or the technologies that you've chosen to retrofit your property, have a high embodied carbon content, coupled with the decarbonisation of the grid. If that follows a very sharp trajectory, you can see a scenario where graph sort of flatlines and never actually goes below zero. And in this case, although you've spent a lot of money and you've tried your best to do good for the environment, you've actually only added carbon to the atmosphere. You haven't actually taken any away, or you've made no carbon savings. And so this is why it's so important to look at whole life carbon, rather, which whole life carbon is basically the embodied carbon plus the operational carbon. And you can't just look at operational carbon exclusively. It's so important to look at the upfront embodied carbon as well. Some of the challenges that we face in trying to analyze the embodied carbon is we have what's called environmental product declarations, EPDs, and these are hard to come by, especially for building services. So, for example, in our case study, we could find no information about the heat pump that was put in, no embodied carbon information. And in this case, we had to make a judgment call based on a similar product. But yeah, the availability of embodied carbon information is just not there at the moment. There are EPDs available for certain materials, such as insulation products, generally pretty good, pretty easy to find those EPDs. However, they are difficult to interpret. If you're not an expert in reading EPDs, I wish you luck in actually finding out what the embodied carbon of the product is. Here's an example of one, no names mentioned, but they're all about the same. On page 6 of 9 of the document, you find a line in a table where you have to add two figures together to work out the upfront, or sorry, the embodied carbon of that product. So it's certainly not information that is readily available to the consumer, and it should be, because it's such an important consideration. So what are the solutions then? What can be done about this? Well, I think it's obvious. We need better, readily available whole life carbon or embodied carbon information, which basically means better EPDs from the manufacturers of these products and of these materials. I would recommend something that we're all familiar with, which is the sort of equivalent to an energy rating that we get on products and on houses, like the EPC rating, which looks at obviously operational energy efficiency. There should be, side by side, there should be an embodied carbon rating with a number giving you the total figure for the embodied carbon of that particular product or material. This would enable you at a glance to look at how efficient the product is, as well as how much carbon's gone into manufacturing that product or material. Naturally, the solution is going to be largely down to how the government, what approach the government takes. So, you know, as mentioned earlier, there can be a carrot or stick approach. There could be incentives in relation to choosing low embodied carbon products for retrofit, but it will probably fall more onto regulation, similar where the London plan has taken the initiative in requiring a whole life carbon assessment for buildings. However, that only relates to new buildings, and it doesn't necessarily cover retrofitting existing building stock, which is going to be a huge piece of the pie in terms of our building stock by the year 2050. We need to look at consumer behavior in terms of our choices. How we do this? Well, we have to actually look into what the materials are that have gone into products. You know, in terms of heat pumps, is if it's a system that has a lot of copper pipe work or a lot of metal in the product, instinctively this is going to be a product that's got a high embodied carbon content. A monoblock, so that would be a split system heat pump with an indoor and an outdoor unit. A monoblock heat pump is going to have less overall pipe work. Also, a monoblock heat pump, which is self-contained, is less likely to leak refrigerant gases, which again is another consideration when looking at the sort of equivalent carbon emissions of the product. We need to consider, is the product or material locally manufactured? Is there a high transport carbon cost of the material? If your material is being shipped from halfway across the planet, there's naturally going to be a high carbon contact in transporting that material or product to site. So there is, even if the information isn't readily available, there are some common sense sort of approaches we can take to determining whether there is a high embodied carbon content. Lastly, I would say make use of a tool such as our matrix tool, which is obviously not a real tool yet, but we would hope to see that the government or industry would produce comparison tools that you could quite easily go into a website, plug in, you know, what retrofit measures you would like to take, and select from a drop-down list what sort of, you know, the exact products that you need to put in, the quantities of those, and it would tell you this is your annual energy savings. However, this is how much embodied carbon has gone into those products and materials, and therefore the carbon payback is going to be X amount of years. So you will know your financial payback, which we are all very concerned about, but you'll also know your carbon payback. And so yeah, that sort of brings me to the end of my presentation, but I welcome any questions that there might be in relation to what I've talked about. So thanks very much for your attention.
Okay, thank you very much, Chris. You can hear me now, Chris?
Yes, I can, yeah.
Great, okay. So we have some questions. The first one would be, on a larger scale, how does offsetting opportunities play into your tool and your modeling?
So the offsetting would probably sort of link into decarbonisation of the grid, in the sense that it will deal with reducing the carbon content of the energy that's used. However, we're not necessarily able to deal with the embodied carbon by offsetting. If a country that's manufacturing our products is still using a highly carbon intensive fossil fuels to manufacture those, I mean, yes, offsetting, it does help, but it won't get us to a net zero scenario. And so it's an easy measure to take, easier perhaps than decarbonisation, true decarbonisation, where you move away from fossil fuels. There are better ways perhaps of offsetting, and this I touched on this, but if a power station runs on a biomass material and then incorporates carbon capture and storage, you're actually creating electricity and removing carbon from the atmosphere. It comes at a high cost, and this is why I say it's you know, offsetting. I imagine you mean by offsetting, I imagine you mean sort of planting trees in another country, but yeah, it's part of the picture, but I don't think it's going to get us to where we need to be.
Okay, I was thinking of, you were talking about different sorts of heat pump. And when I bought my heat pump, I didn't consider some of the questions you were raising. But, you know, in retrospect, should I have been saying, well, you know, is Mitsubishi, in my case, going to offset the carbon content of my heat pump, for instance?
Right. Well, yeah, I mean, I would say that's a start point for companies, you know, if they're not able to manufacture their products, which is understandable. You know, if the factories can't yet manufacture the products using low carbon or zero carbon energy, then yes, offsetting is a interim temporary measure. It's better than doing
zero
nothing.
carbon manufacture is better.
Correct. Yeah.
Yeah. Okay. Next question is, and I don't understand it, but hopefully you do. Does the carbon calculation account for scope 1, scope 2, and scope 3?
So scope 1 is obviously yes. Scope 2 and 3, I have to sort of jog my memory, but the sort of indirect emissions. I mean, we're looking at, you know, the embodied carbon would take into consideration transport to and from site, you know, the end of life of a material. So these are all the elements that you would need to factor in when you assign a figure for the embodied carbon of that product. So I think scope 2 and 3 emissions are more relating to perhaps, you know, a business case scenario, you know, an organization scenario where they're looking at their upstream emissions and things like that. So it doesn't necessarily relate that well to a physical product, but certainly if the manufacturers of these products and materials are considering their scope 2 and 3 emissions, then yes, this is going to push and lead those companies to reduce the embodied carbon of the products. It's sort of a roundabout way of getting to where we want to be.
Okay. The next question will take me a little while to read out. How long do you think it will take to properly debug valid options, noting the problems with cavity wall insulation, maintenance and insurance problems encountered with spray foam insulation, difficult to resolve cold bridging, mold, damp problems with external thermal insulation, et cetera, because the writer wants to improve his property, but he's nervous.
Yeah, so I sort of intentionally haven't gone into detail in my talk because it is complex. You know, not every building you can just slap insulation on the outside. You know, there can be issues with interstitial condensation. Certain buildings are meant to breathe, and certainly older buildings are not going to behave or perform well with an airtight sort of external wall insulation product being added. This is going to have to be looked at case by case scenario. And when you ask about, you know, will the insurers sort of come on board, and you know, I'm not able to answer on that side of things. I would say that things move slowly, unfortunately, in the construction industry. You know, there's a huge sort of lag effect, and banks, lenders, and insurers sort of are the last to kind of come to the party. The technology is out there. There are means and ways to effectively insulate sort of any type of wall and do it without creating cold bridge risk and interstitial condensation risk. However, even saying that, a spray foam product is not necessarily going to have a low embodied carbon. So although it might be a suitable product from physical point of view, we still need to look at the embodied carbon of that product.
Okay. Can you see a time when suppliers of equipment and services have to declare embodied carbon as standard in clear terms?
Yes, I certainly think that will be the case. I think what I'm talking about here is it's relatively new information. I mean, academic papers are being published as we speak because this has happened so rapidly in the last decade, where we've come into the scenario where embodied carbon is now a much bigger piece of the pie. it's only a matter of time, in my opinion, where government policy, EU-wide regulation is going to insist that these companies, well, they already have to provide the information in the environmental performance declarations. The information is there. It's just not readily and easily available. And it's certainly not available for building services products. So yes, I think it will need to be there for all types of products and also more easily accessed.
Okay. Do you have a view on what's the impact on the carbon footprint of the use of a Powerwall storage system with PV solar panels?
So Tesla Powerwall. I haven't looked directly into the Powerwall itself. I've read a lot of conflicting opinions on lithium ion. I think, well, I have actually looked at solar PV panels, and there are scenarios where PV does not sort of pay itself. The upfront carbon is not paid back. Generally speaking, though, if a solar panel is installed correctly, so it's not foolishly installed on a north-facing roof or something like that, it will, generally speaking, I mean, there are various studies that have been performed, but generally sort of 3 to 5 year carbon payback, sometimes less. Obviously, the more sunny the country or the location, that will be a quicker payback. Bearing in mind, though, that these assume a certain electricity grid intensity. So if the electricity grid decarbonizes very fast over the next few years, you may have assumed that your lithium-ion batteries and solar panels the embodied carbon will be paid back. However, as your annual carbon savings get less and less, because the grid, that electricity that you're displacing is less and less carbon intensive, you're actually pushing out your carbon payback further and further. And it's a tricky sort of situation to be in. It's a bit of a catch-22. We want to decarbonize the grid, but it does mean that all the measures we take now, which have a high upfront embodied carbon, are going to take longer and longer to be paid back as we decarbonize the grid.
Sure. Okay. What's the next steps for your tool? Is it something that you think will be communicated more widely as a basis for industry and government?
I'm not sure about our specific tool. I mean, we will just submit our assignments, and perhaps we will take it further with our tutor, who's that's Dr. Francesco Camponi. He's very actively involved in the embodied carbon sort of debate at the moment. And I think he is likely to want to take this tool forward and at least sort of look at all the implications of the data that the tool can produce. And then he will present these sort of academic papers, and hopefully they will be picked up and sort of brought in front of the right people so that it can be put forward into policy. But in terms of our specific tool, I mean, it is just a prototype. It's not rocket science what we're doing. It's just taking a lot of numbers and crunching them together. I think it would be great if someone creates an online, freely available tool that anyone can use to plug in their information and get answers out. I think that would be, and on a sort of global scale, that you can choose your country and it'll know what the carbon intensity of the grid will be there. So I think that's going to be important. I think somebody will do that.
Right. Okay. Does your model include any factor for occupant behavior, the trade-off of carbon against comfort?
No, it doesn't. That would be an interesting sort of perhaps slider mechanism you could add on the front end. Are we a high use or medium use or low use family or business? Because yeah, this sort of opens up a can of worms. But the EPC rating, as everyone knows, is flawed in a sense because it assumes a standard occupation and a standard usage pattern, and quite often it's nowhere near what's actually the case. So when you assume your savings, your annual savings, it's done based on these assumptions. I would say the way our tool could deal with that is when you model the savings, perhaps in another piece of software, you could adjust the occupancy patterns, and that would give you a different annual saving for whatever measure you take.
Yeah.
So it, in a roundabout way, it can be sort of included in the tool.
Yeah, okay. Would you consider fabric first to be a good approach when prioritizing retrofitting carbon saving?
I've been sort of trained to say yes. That's my gut instinct. The answer to everything seems to be fabric first. I think I say that cautiously now. I would say fabric first if you're using the right materials. We can't just choose, perhaps the cheapest and most readily available material. It might save the most money, but like I said, this correlation with carbon and cost saving is, the correlation is sort of diverging a bit. And yes, we should, we should do what we can to improve the energy efficiency of our buildings, because there is no guarantee that the grid is going to decarbonize further. It's projected to, but at the moment it's a prediction.
Sure.
So, there you go.
Okay. I'm being asked whether we've got any link or info on EPDs, please.
So it's generally each manufacturer sort of provides them on their own website. There are, I don't think there are any UK based, but there are EU websites where they send you to the right location for a specific product. So I don't think I've got any that I could immediately put in the chat.
Right.
But if you were to Google EPDs, for whatever specific product you're looking for, it generally, if it's an insulation product or something like that, will generally take you to the manufacturer's website. Quite easy to get hold of them for insulation products.
Okay. Okay. Are heat pumps generally found to be the best heating solution for decarbonising buildings, or are there other alternatives which are better?
Heat pumps certainly seem to be the best product when you're talking about heat. There aren't any other products at the moment that I'm aware of, or types of product that will do a better job, purely because the heat pump is running on electricity, and our electricity is very low carbon, has become low carbon intensity. So this has changed very fast. I mean, I'm sure many of you remember when CHP was being pushed sort of in the late noughties, I think that's what you call it, so 2008, 9, those sort of years. Combined heat and power, which runs off gas, was heavily promoted, and then that changed, and biomass for a while in suitable properties was being promoted. Now, for good reason, heat pumps are the go-to for heating, and I have no affiliation with any heat pump company.
Although, of course, there are properties for which heat pumps really are not appropriate. You just can't fit them.
Challenge with heat pumps is the low-grade heat that it provides. So a typical boiler provides your LTHW at 80 and a return 60 degrees. Heat pumps like to operate much lower than that, say 45, maybe 55 degrees. So the property type, as Greg correctly mentioned, is you are restricted. It's not going to be suitable for a very leaky older property. You would either need to increase the size of the radiators, or first upgrade the fabric of the property, get it well insulated, and then put in a heat pump. Just because your radiators won't be able to have the same output when they're running at a lower flow temperature. It's as simple as that. And the heat pump loses all its efficiency when you try to run it at a higher temperature. That's just the nature of heat pumps. Okay.
Do you have a comment on how the reduction in embodied carbon in buildings can help to offset the vehicle carbon emissions in cities?
Sorry, say that one again, Greg.
Well, how can reduction of embodied carbon in buildings help to offset the vehicle carbon emissions in cities?
Well, I don't think it, well, I guess it will, you know, if we have our pie that I've shown a few times, if we're reducing any segment of the pie, we're reducing the overall carbon emissions, you know, the global CO2 picture. I don't think we would say that we're offsetting transport emissions by doing that. We're simply reducing the embodied carbon of one of the, or the carbon content of one of those pieces of the pie. So, you know, there's not much we can do. The only way you can really offset carbon in the technical sense of the word is extract it from the atmosphere. That's, you know, anything else, we're not offsetting carbon, we're actually just saving carbon. So, for example, if all the coal power stations in the world disappeared, all the fossil fuel power stations disappeared, you would need to extract carbon from the atmosphere in order to offset carbon. You could no longer say, well, I'm running a low carbon building, therefore I'm offsetting carbon. So it's kind of a technicality with the wording, but it obviously helps.
I guess the perfect solution would be if the electricity generation did go negative, as your curve suggested, you know, was a theoretical possibility, then the answer would be, well, burn more electricity. Then you're offsetting.
Well, that's right. If what they're predicting is true, that we are going to generate electricity with negative carbon emissions, then well, we're going to be in a very interesting scenario where we're going to be incentivized to use electricity.
Indeed. So next one, do you take into account the life cycle of the product? For example, if you're planning for net zero 2050 and install products that have a 15-year lifespan, it will need to be replaced in 2037. So do you calculate the additional embodied carbon when you go through the replacement cycle?
Yeah, absolutely, yes. So that's an important consideration. And you have to make some sort of a prediction on the embodied carbon requirement in 15 years' time for the same product. So we sort of set I mean, the UK prediction is that industry will decarbonize by 87% 2050. So that means that in 15 years' time, the embodied carbon of that product should have reduced by perhaps half. But yeah, we do need to look at, you're absolutely right, we do need to look at replacement. This is important for solar PV, where you have to replace the inverter. But yeah, anything that has a limited lifespan, less than the life of the building, you have to add in the repeated you know, embodied carbon of that.
Can we tackle the retrofit of UK's housing stock without government action and funding to meet zero carbon targets? Housing represents 30+% of the UK's CO2, and we need to retrofit a home every 2 minutes to meet the targets.
So sort of off the record, I'd say I don't think we are going to meet the targets. And this isn't my opinion. This is the opinion of professors who have analyzed the figures. And like you say, I wouldn't have known off the top of my head that it was once every 2 minutes. But yeah, we can't do it without, we won't be getting close to that without government incentive and policy, simply because it is a high financial cost to fully retrofit a building. I mean, the figures are, you know, our case study, I think, was about £70,000. These are big numbers if you're looking at, you know, doing a deep retrofit. This is going to have to come from the public purse. We can't expect people, it's going to be difficult to incentivize people to take out some kind of a Green Deal loan for 70K to upgrade their own home. That being said, perhaps in the next decade or so, certain products will come on the market that, well, hopefully heat pumps will become a lot cheaper, and perhaps deep retrofit will look slightly different with a much lower carbon intensity grid. So I'm hopeful that the financial cost of deep retrofit will come down significantly to the point where there is a business case. We can decide, yes, I want to retrofit my house because I'm going to see a payback within my own lifetime. So we're not there yet, unfortunately.
Yeah, okay. What about ways of reducing the embodied carbon in the basic construction materials for buildings? Have we found ways in the last 10 or 15 years of doing that very much?
That's been slow. So there's been probably, I'd say, very little progress there. That and perhaps the airline industry have been slow to decarbonize. Having said that, today I did see an article about a way of producing concrete with net zero emissions, and I'm hoping that it's not because they're just offsetting the emissions. It's a sort of University of Cambridge researcher, so it's not something that's readily available. It hasn't come to market yet, but yeah, to answer your question, the construction industry has not yet been able to find ways of decarbonizing manufacture, and there's no sort of golden bullet, I think.
Sure. Okay, and I think the last question is, do you believe the UK will hit net zero by 2050? And it goes on. I mean, I think you've said you have your doubts, but it then goes on to cite a number of problems, emission from international air travel, international shipping, UK crown dependencies, overseas territories, burning of biomass, the use of peatland, production of goods and services overseas. There are an awful lot of things which have to be added to the net zero calculation.
Well, you're correct, and the list goes on. I don't think we will be at net zero by 2050, but we will, I think, have made huge steps towards that. I don't think we should just sit back and give up. Mm-hmm. Net zero, it is, at the end of the day, it's a catchphrase. It's, depending on how you look at the definition, it's kind of there are various ways of defining net zero. Perhaps the way that it's currently defined is not what we should focus too much on, because I don't think it needs to be an absolute target. I think as long as we get to a sustainable, to throw the word out there, but a solution that the world can cope with. We don't necessarily need to reach net zero in order to carry on living.
Of course. Okay, well, and the ones I haven't read out are the various comments. Thanking you very much for an interesting presentation. So I'd like to thank you too. I think it was a very interesting presentation. Thank you for beaming in from Greece to talk to us tonight. So thank you, Chris. And with that, I'd like to say thank you very much to everybody for joining us. I hope you've enjoyed this season of talks, and we look forward to seeing you again in October in the Hawth in Crawley. Thank you very much, everybody, and good night.
Thanks, everyone.